Okay, we have a quiz here, and what we're leading up to is, well, this is what you had homework on, okay? Um, what we're going to lead up to is parallel and perpendicular lines. We're going to start with the line that we get here, and then we're going to figure out how would you get a line parallel to this one? How would you get a line perpendicular to it? Right now, let's just talk about this because people had a little trouble with this, okay? Now, how do you find the equation of a line? You got to get this in your head, okay? It's a bad looking y, but I think you can see it's a y. Y equals mx plus b. It's called the slope-intercept form. You can review what we did last time. I'm not going to write it all out. That's one form, and that's a form we're probably going to use because for this situation, it's the simplest form, okay? And then you've also got x over a plus y over b equals 1. It's called the intercept form. Now, you did an assignment on intercepts. If you know the x and y intercepts, you just put the x-intercept there and the y-intercept here. But this is algebraically a little more complicated than this. Now, you've got other equations, but we're just going to use this one. Okay, so use y equals mx plus b. Find m, which is the slope. Slope is rise over run. Now, from this point to this point, I can draw two arrows, one vertical and one horizontal. That vertical arrow didn't go quite far enough. Okay. You know, this arrow is on a line where x is constant. And this arrow is on a line where y is constant. So everywhere on this line, x equals -4. Everywhere on this line, y equals -3. This line, y equals 7. And on this line, x equals 6. Line y equals -3. It's helpful to sketch those lines when you have 2 points. It's not necessary, but it's helpful. Now, how far is it from here to here? Well, you're going from 7 down to -3. Means you got to go from 7, you got to hit 0, which might be about here, and you're already down 7. Then you got to go down 3 more, so you got to go down 10 units, right? And this is your rise. Now, the arithmetic is you subtract where you start from where you end. It's -3 minus 7, which is -10. I explained a lot about that last time. I'm not going to go through, I'm not going to repeat the detail that I used last time, but I recommend that you check out the video. You can also check out the AI summary. Those AI summaries are pretty good. Usually what the AI comes up with is correct, and sometimes I've got to insert a few things. I very seldom have to take something out of what they say, though. Sometimes I want a little more detail, so I'll type in a little more detail in italics. You can see there in summary what we did, but you really ought to check out the video so that you pick up on the stuff that isn't in the summary. The summary is just, summary is this big and the video is huge compared to the summary. You get a lot more information in the video. You want to try to process that. Okay, so the rise is -10. The run from -4 to 6. Well, if you go from -4 to 0, that's 4 units. You go 6 more, that's 10. So the run is, of course, 6 minus negative, did I say 10? It's 9. So I don't know what I got in my feeble brain. But if you go from -3 to 0, it's 3 units, and 6 more units is 9. Okay? And you can get that in one calculation just by subtracting where you start from where you end. Now, the fact that the rise is -10 is important. Said 4? Hang on a minute. Let's see what we got to fix. Do I have something wrong up here? Corrected. I said we're going from -3 because -3 is right there, and that's what my eye caught. Sometimes I'm going to do that. Watch me. Okay. Think of going from the line x equals -4 to the line x equals 6. And if you look at those two lines, you won't look at this and you won't get it wrong. Okay. So yes, run is 6 minus -4, which is 10. And again, thank you. Okay, so the slope is rise divided by run. And that's -10 over 10. Now, some people got 10 over 10, had the right numbers, but remember that that arrow's downward, that makes the rise negative. And we'll usually go, I'm just going to say, and you can do it any way you want, but go from the leftmost point to the rightmost and draw this picture. That reinforces what the slope is, and it reinforces why you're doing it. Okay? Anyway, that gives you -1. So we have the slope. So now y equals -1 times x plus b, or just y. Actually, I should write that y. Y equals -1 times x, or just y equals -x plus b. Okay, now we use either the left point or the right point. There's an odd number of people here, so you need to vote. Everybody hold their thumb up straight. Okay, everybody. Now point it to the right or to the left. I don't care. Okay, we got 2 votes for left. You gonna vote? You gotta go with everybody. You lose if you're not gonna affect the result. Okay, so we use the point on the left, -4, -7. X equals -4, y equals 7. Well, we're going to plug that in here. We're going to get 7 equals -x, which will be negative of -4 plus b, which means, of course, that 7 equals 4 plus b. So we're going to subtract 4 from both sides. We solve for b and we get b equals 3. And okay, now that we know b equals 3 and m equals 1, we've got a number for m, which is -1. That gives us y equals -x. And we got a number for B, which is 3. Okay. Now that, I believe, is our equation, because if x equals 6, y should come out -3. That checks, because that gives us the coordinates of that second point, right? And we could plug -4 in. Okay. If we plug in -4, we get negative of -4, which is 4, and 4 plus 3 gives us 7. So we could plug each point in just to make sure each point satisfies, or make sure the equation is satisfied by each point on the graph. And that's the procedure that you really need to follow in order to master this process. Now, there are formulas. If you can remember those formulas, there are a bunch of them. You don't need to do this geometrically, but it's important to understand what the formulas mean. And I kind of recommend that you do it this way. Then maybe you do it with using a formula. And we talked about that last time. So you want to take a good look at what we did. Okay, now we're going to use this equation. We're going to do several things with it. The first thing we're going to do is what I asked you. Find the intercepts. Find y when x equals 9. Find x when y equals 12. Okay, so we have an equation y equals -x plus 3. X-intercept first one, y equals 0. So we solve 0 equals -x plus 3. When we solve that, we'll get the x-intercept. The solution is obvious, and it's not always going to be that obvious, but you solve the equation and you get x. Okay? The x-intercept occurs at the point 3, 0. Well, we put that information into our graph. Where's the x-axis? Where's the y-axis? Well, the y-axis is at x equals 0. Where's x equals 0? Well, it's between 7 and -3. It's quite a bit closer to -3, so I'm going to say this is probably the line x equals 0, y equals 0, which makes it the x-axis. And I'll make the note that y equals 0 on the x-axis. That's important to remember, important to understand, important to reinforce. Then we want the x-axis. Well, x-axis is between -4 and 6. Halfway between -4 and 6 is -1. So the x-axis is probably, or the y-axis, I'm sorry, is probably about here. So there's the y-axis. Now, if I draw a line through these 2 points, it intersects the x-axis right here. Now, if this is 0 and this is 6, x equals 3 should be halfway between 0 and 6, but I wasn't real careful. My hand sketch graph isn't totally accurate. My x-axis or my y-axis is probably a little too far this way, or my x-axis is maybe a little too high. Um, but there's the x-intercept, which is 3, 0. Didn't come out perfectly in this graph. 3 would be just, half an inch to the right. But that's what solving this equation gave us. Now remember what I said, x-intercept occurs when y equals 0. Y equals 0 is the x-axis. So we replace y with 0 and solve for x. Of course, you had an assignment last week on the intercepts, okay? So you might want to review that if you're not, if you don't recognize that right away. Okay, so y-intercept when x equals 0. Okay, here's the y-axis. Say x equals 0 on the y-axis. So the y-intercept occurs when x equals 0. So solve y equals negative 0 plus 3. What do you get? You get y equals 3, so the y-intercept is at the point 3, 0. Oh, sorry, 0, 3. So that would be this point. Now we want to find y when x equals 9. How do we find y when x equals 9? X equals 9, then y, which equals negative x plus 3, equals negative 9 plus 3, which is negative 6. The point 9, negative 6 is on the line. Now you see, if 6 is here, 9 ought to be about here. So if we draw the line x equals 9 and look at where the graph intersects, okay, here's x equals 0. Here's where y equals negative 3. It's very plausible that y would equal negative 6 at this point. I'm not going to attempt to draw that, but you can indicate this point. And if you're drawing your own graph, you probably want to put the coordinates in there. Then we're asked to find x when y equals 12. Well, if y equals 12, we'll replace y by 12. Solve for that for x, and we get x equals negative 9. On our graph, here's X equals 0. Here's X equals -4. -9 would be over here. How high would we have to go to meet the line? 12 seems like a reasonable no. Okay, you want to draw that in on your graph. Okay. Want to practice these things also when you're doing your homework. By halfway through your homework, you should be able to do it without looking at notes. Okay, you might not be able to. Right, don't just, sit there with an example in front of you and just follow the example by rote. Because if you do, you're not going to ever learn to bring it out of your memory. It won't be in your memory. Okay. So be sure that when you do the homework, do it in a way that you learn the stuff. Okay. So you come in here knowing what these procedures are. It takes a lot. It takes some effort, but that's the way you really want to do it. So, and I've always got to warn people, especially distance students, many times, that I see a lot of perfect homework, and people come in and take a test and can't do it. Okay, so you got to get this stuff into your head first, so you come in and do the quiz, then so you do the homework. Okay. I mentioned a test. We should have had a test already. With all the weather disruptions, things are just crazy. Um, so by the end of next week, we will have covered everything up through linear equations. And we're going to have a test, which will be due the week we come back from spring break. Saturday next week, we start. Okay. I've put a document in the assignments page for last time. Something like practice problems A, B with solutions. So we've got practice problems there. And I don't remember how many versions that thing I put down there, maybe 10, maybe 40 versions. And there are probably 50 problems in each version. So there's an unlimited supply of problems. And if you want more, the program that generates these problems. You want 1,000,000 problems, I'll send you a file of 1,000,000 problems. Okay? Oh, you don't need that many. So I recommend that you spend a good bit of time practicing the problems that you see there. I'll give you a little more guidance. Right now, I think it would be problems up through the one that's numbered 200. But I'll put that into the assignments page when I put it up today. You want to start reviewing what we've done and practice so that you can do these things under test conditions where you're not going to have notes or anything. Okay? Practice. And I think you can do real well. If you're behind on the homework, be sure to catch up. Um, You'll have a break week after next. If you're still behind at that point, that might give you a chance to get caught up. And well, anyhow, we're going to go on. Okay. Now we've got this line, and I'm going to draw this line again. I'll draw an X and a Y axis. And I've got the point 6, -3. So we'll put y equals 6 out about here. X equals 6, sorry. And y equals -3 about here. And then x equals -4 is going to go about here. -4 is about 2/3 of 6. So that looks about right. And y equals 7 up here. So if that's 4, that would be 4, 8, 7 would be about here. We have this point and this point. And here's our line. And the equation of the line is y equals -x plus 3. You know, I can't get this line to behave at all. The x-intercept should be halfway between 0 and 6. And it just isn't. Oh, I'm going to fix it. I said this is -4 because my eye caught this. I got to do something about that eye. Y equals 7 line should have been a little higher. Okay. This is -3. Here's 3, 6, 9, and 7 ought to be up more like here. So when I draw the line through these points, the x-intercept is going to be closer to where it should be. I think maybe I overcompensated because it's a little too far to the right this time, but here's the point, 3, 0 that we found. Now we can extend this line on. If x is 6 here, add 3 more. X equals 9 should be here, and this point should be 9, -6. If we extend the line over this way, till we get up to y equals 12, which will be up pretty close to the top of the board, point match. There we go. Then x equals -9 will be, there's 4, there would be -8, here's -9. This point would be -9, 12. That's all the information that we obtained from the quiz problem. Now, the question we want to ask today is, can we find a line parallel y equals -x plus 3 through the point, well, let's just say through this point. Move it a little to the left. Say that this point is 6, 4. Well, can you imagine what that line would look like? The line that goes through this point and is parallel to this line? Well, just on your paper, just 2 pencil strokes, okay? Sketch me a line with about this slope. Doesn't have to be on a coordinate axis. You don't have to label points. Just somewhere. Sketch me a line that's about in this direction, and then another line through a point somewhat above this one that's parallel to it. So just two parallel lines with about this slope. Okay. I knew you knew what that meant. It just, you know, and just gonna look over here, just only two parallel. Okay, that's, that's all you really needed to do. Okay, now, we got two parallel lines. This one and a line through here. Now, let's see if it's gonna be parallel. I'm gonna do a better line if I have the points to aim at. Stroke slipped. Okay, well, not great, but we assume this is parallel line, okay? This line is parallel to y equals negative x plus 3. So what do we know about this line? Okay. We know what's its slope. So slope is same as this one. That's what parallel means. They have the same slope. When I ask you to draw two lines, you drew two lines that were nice and parallel. Okay, they clearly have the same slope. Okay, they're equally steep, and the slope is either up or down, depending on what the first line was. Okay, so slope of y equals negative x plus 3 is negative 1. Slopes must be equal. Okay. The slope of the new line is negative 1. Okay. The equation is y equals mx plus b. With m equal to negative 1. So y equals negative x plus b. The point is 6/4. So y is 4, x is 6. So 4 equals negative 6 plus b. We solve that for b and we get b equals 10. Thus, the equation is y equals negative x plus 10. Okay. So the x-intercept ought to be 10, and the y-intercept ought to also be 10. Okay. And one thing I didn't label over here was the y-intercept. The original line, that was 0, 3. For the new line, it ought to be 0, 10. Now, when I drew this part of the line, I was aiming at a point that was just a little bit too high. This distance here and this distance here would give me a point about here. And if I draw that, it ought to be, okay, the line looks a whole lot better. Now, also, what's the y-intercept of this line? Is this point up here? Zero, 10? Looks reasonable. If this is where y equals 7, if I go 3 more, I get here. Considering it's a hand sketch graph, we're not that far off. It looks a little low, but it's okay. And where does the line intercept the x-axis? Well, we said x equals 6 here. We said x equals 9 here. 10, 0 isn't a big stretch. It's completely reasonable. That makes sense? Now let's say that we want a line perpendicular to the two lines. So let's try this. Let's let that line go through the 0.64, just like the previous one. Now, the thing you got to know about a perpendicular line have negative reciprocal slopes. Okay, remember that? Yeah, had a look of recognition on your face. Okay, that's something that got drilled into people years ago. Recently, I don't know. I think people still pretty much know it because they've had the prerequisite courses. Anyhow, whether you do or not, now you do. Now, what do we mean by negative reciprocal? Slope of the y equals negative x plus 3 line is negative 1. To do the reciprocal of a number, you divide it into 1. You write 1 over whatever that number is, and you get the reciprocal of that number. Now, if you don't remember that, it's okay. Negative 1 isn't a particularly good number to use for an example here, but open math will make that very clear. You see plenty of examples. It's something that doesn't usually give people any trouble. Well, if you divide 1 by -1, you get -1. But that isn't the slope that we're looking for. We're looking for the negative reciprocal. So this is the reciprocal. The negative reciprocal, you put another negative in front of the reciprocal, and you get 1. So we need a line 6, 4 with slope 1. Well, I'm going to have to move this board over a little bit, so what I've written will be off the screen. Actually, it's not only a little bit of it is off the screen, but so that equation y equals mx plus b becomes y equals 1x plus b. And the point 6, 4 tells us that 4 equals 1 times 6 plus b. That is 4 then equals 6 plus b. And we solve for b, subtract 6 from both sides. Get b equals -2. So the equation y equals 1x, and we'll just write x instead of 1x, plus b becomes y equals x minus 2. Okay. Now, let me ask you, somewhere in your paper, just off to the side somewhere, draw me a line with about this slope. You don't have to put it on the axis or anything, and draw a line perpendicular to it. If you don't know what perpendicular is, we'll clarify that, but if you do, then I won't have to say much about it. Okay, I sure wish Zoom showed me whether I was recording or not, but it doesn't, at least not for long. Trying to find the line perpendicular to y equals -x plus 3 through the point 6, 4. Perpendicular lines have negative reciprocal slopes. I believe I was recording when I said this. I'll say this much fairly quickly. The slope of this line is -1. It's over a little bit. The reciprocal of -1, what's reciprocal mean? Means you do 1 divided by 1 over that number. 1 over -1 is the reciprocal of -1. And of course, if you divide 1 by -1, you get -1. So the reciprocal of the slope is -1. A negative reciprocal is the negative of -1, which is 1. And that's the slope that we want. So we need a line through the point 6, 4, having slope 1. So our equation, y equals mx plus b, becomes y equals 1x plus b. The point 6, 4 is on the line. So we use x equals 6 and y equals 4. Plug the 4 in for y, we get it here. We get 4 on the left-hand side, plug the 6 in for x, and we have 1 times x plus b. we solve this equation. Well, we simplify it. We get 4 equals 6 plus b. We subtract 6 from both sides to get b. We get b equals -2. So our equation is y equals x minus 2. Now, I paused the video when I asked everybody to sketch me 2 perpendicular lines. So perpendicular means what? It means right angle. So here is a picture of 2 perpendicular lines. Okay. And the 2 lines make right angles with one another. It's a familiar idea. I think maybe the word perpendicular, just maybe people have a little confusion over that. Okay, so we sketched the line perpendicular to the second line that we drew before, the one that was parallel to the original line, through the point 6,4. And that's approximately perpendicular. Now, how well did I do perpendicular? Probably not that well. Let's go ahead and put a piece of paper here. Yeah, you see my line has, the slope was a little bit off. Of course, that would have made everything worse. Okay, so there's the line. We just kind of observe that the line is y equals x minus 2. Its slope is 1. It goes through the point 6,4. They can check all that out. And its y-intercept should be -2. Well, the y-intercept here is just a little ways above the line y equals 3. So it looks like it's a little bit low here. Maybe it should have been up a little bit more. And the x-intercept should be when y equals 0 at x equals 2. It looks like we missed that one by a little bit too. X equals 2 should be over here. So our sketch isn't perfect. In any case, we have a picture and we have the point. Now I've asked everybody to work on problem line through 5, -7, the slope 2/3. And then if you get that line perpendicular to that one through the point -4, 2. So I'm just going to see how everybody's doing. Then I'll write down a quick solution because we're almost out of time. Okay, now we have limited time, so I'm going to do this pretty quickly. First problem. Well, you're going to get y equals 2/3 x minus 7. If you substitute the x's and y's, you're going to get -7 equals 2/3 of 5 minus 7. If you multiply both sides by 3, you get 3 times -7 equals 3 times 2/3 of 5 plus 7. So you get -21. 3 times 2/3 is just 2. So you get 2 times 5, which is 10. I'll write this over here. 3 times 2/3 of 5 equals, we write that 3/1 times 2/3 times 5. The 3 in a denominator here, well, that equals 3 times 2 times 5 over 3. We have a 3 in the denominator and a 3 in the numerator. So the 3 divides out, we end up with 2.2 times 5, which is 10. We have then 10 plus 21. I put a -7 there. Should have been plus b. My eye caught that and I wrote it down. 3 times the 2/3 of 5 gives us 10. 3 times b gives us 3b. And now we have an easy equation to solve. We just subtract 10 from both sides and we get b equals -31/10. So our equation is y equals 2/3 x minus 31/10. Okay. Now you can also, if you memorize equations well, you memorize the slope, point slope form, y minus y1 equals m times x minus x1. Okay. And that's all right too. Okay, line perpendicular to the preceding line. I'm not going to have time to do this one because we've got to get ready for the next class and you all probably have some place to go. But this line should have slope -3/2, -4/2. Slope here is 2/3. This slope is the negative reciprocal. Okay. Negative reciprocal 3/2. 2/3 is -3/2. Fair enough. Now, I do recommend that you be able to draw the pictures and understand it thoroughly that way. But for this course, it's sufficient if you can memorize the formulas and use them. Okay. You'll have a better understanding. It'll do you better in later courses if you can get both the pictures and the formulas. But one or the other is going to be fine.